Welcome back to the Geology Dean's Masterclass. In our last episode, we introduced the fascinating world of metamorphic rocks. Today, we're diving deeper into the powerful forces that forge them, the agents of metamorphism. Think of these agents as the master sculptors of the Earth's crust, transforming existing rocks into entirely new creations. So, what are these powerful agents? There are three primary forces at play: heat, pressure, and chemically active fluids. Let's start with heat. Heat is perhaps the most crucial agent. It provides the energy needed to break existing chemical bonds and drive recrystallization. As rocks are buried deeper into the earth or come into contact with molten magma, they heat up. This thermal energy allows atoms within the minerals to migrate and rearrange themselves into new, more stable crystal structures. Imagine taking a pile of loose sand and heating it until it fuses into a solid piece of glass. That's a simplified analogy for how heat works. It doesn't melt the rock entirely, but it fundamentally changes its texture and mineralogy, creating new minerals that are stable at higher temperatures. Next up is pressure. Pressure acts like a giant vice, squeezing rocks from all directions. There are two main types. The first is confining pressure, which is equal in all directions, like the pressure a diver feels deep underwater. This pressure compacts the rock, reducing pore space and making it denser. The second, and often more dramatic, is differential stress. This is when pressure is stronger in one direction than others, usually due to tectonic plate collisions. This directed pressure forces minerals to align themselves in parallel layers, creating a distinctively banded or layered appearance called foliation. This is how we get rocks like slate, schist, and gneiss, each with its unique texture created by pressure reorganizing the mineral grains. Finally, we have chemically active fluids. These are hot, water-rich solutions containing dissolved ions that circulate through the fractures and pores within a rock. These fluids act as catalysts, speeding up chemical reactions and transporting elements from one place to another. They can dissolve existing minerals and deposit new ones, a process called metasomatism. This fluid activity can drastically alter a rock's chemical composition, introducing new elements and creating unique mineral assemblages that wouldn't have formed otherwise. Heat, pressure, and fluids rarely act alone. It is their combined influence that determines the final metamorphic rock. The specific combination and intensity of these agents define what we call the metamorphic grade, from low-grade changes at relatively low temperatures and pressures to high-grade transformations under extreme conditions. By studying the minerals present in a metamorphic rock,